Okay, so for number 1, it says a smaller square park has an area of 3,600 square meters. What is the length of one side of the park? This is just going back to our example problem where they were given an area of 90 square meters and then they had to find the length of one side. And so to solve that problem, they knew that the area was 90 square meters, and so to solve it,
158 to your bus.
and so to solve for the area of 90,000 square feet, they had to find the square root. So that's exactly what we're going to do. We're going to find the square root of 36,000 square feet. Now, I know that we didn't talk about 3,600 as one of our square roots that we had to memorize. But we can look and solve for the square root of 36. We know that the square root of 36 is 6. 6 times 6 is 36. And then we're going to take one of our zeros. 60 times 60 is going to give us 3,600 square feet. So the length of one side of the park is 60 meters. 60 meters. Number 2, it says, when completely full, a cube-shaped container will hold 8,000 cubic centimeters of water. What is the length of an edge of the container? So, since we're talking about a cube, right, it's a cube-shaped container, we're going to take the cubed root of 8,000. Again, we didn't talk about the cubed root of 8,000. However, we can solve for the cubed root of 8, in which case we're going to make that 2. The cubed root of 8 is 2, and then we take one of our zeros. 20 times 20 times 20 would give us 8,000. And so our answer is 20 centimeters is the length of one of the edges. Number 3, it says a planter in the shape of a cube has a volume of 1,000 cubic inches. Is the area of the base of the cube greater than or less than 1 square foot? And then explain. So, we're given the volume, so we know we have to take the cubed root of 1,000. The cubed root of 1,000 we have solved before. That was one of the problems that we had to break down into smaller pieces. And so when we broke it down, we found that the cubed root of 1,000 is 10, which means our side length is 10. Now, if we're looking for the area, to find the area, you have to do the length times width. The area is length times width. So in our problem, we would do 10 times 10. And so our area is going to be 100. And so we would say that our area is greater than 1 square foot. Okay, number 4. It says the distance d in feet that a dropped object falls in t seconds is given by the equation d divided by 16 equals t squared. How long does it take for a dropped object to fall 64 feet? So we're simply going to substitute 64 for d. So our problem is 64 divided by 16 equals t squared. When we divide 64 by 16, we should get an answer of 4. And so 4 equals t squared. And then if we're squaring it, we want to do the opposite. So we're going to take the square root of 4. We take the square root of 4, which is 2. Our answer is 2 seconds. Because if we went backwards, we would do 2 squared, which would give us the answer of 4. Number 5. The area of the top face of a small cube is 9 square centimeters. It takes 9 of these small cubes to make a larger cube. What is the volume of the larger cube? So first things first, we have the area. The area is 9, meaning we need to find the length and the width. So we're going to take the square root of 9, and when we take the square root of 9, we get an answer of 3. So on our cube, or on our square, since we're looking at the face, we have 3 and 3. But we're dealing with a cube. And so on our cube, if one side, if this is 3 and then this is 3, if it's a cube, we know all the sides are the same, so that means the height's going to be cubed as 3 as well. So our volume of our cube is actually 27. Now, that is just for the smaller cube, because it says a small cube is 9 centimeters, and so our volume of our cube is 27 centimeters. However, in the problem, it also states that it takes 9 of the small cubes in order to make a larger cube. So to get our answer, we multiply 27 times 9, and when we multiply 27 times 9, you should get 243. The volume of the larger cube should be 243 cubic centimeters. And the last problem, number 6, it says the diagram shows the dimension of Taylor's deck. The area of the deck is 233 square feet. Taylor's going to put a railing along the longest edge. How many feet of railing will she need? So if we have our deck picture here, we know that our first section of the deck, this section right here where it says 8 feet by 8 feet, we can find the area of that, and that is 64. That is our area, is 64. Now, we also know that since it's a square, that this side right here is 8. That's where that x plus 8 comes from. It's from the 8 that's right there. If this area is 64, we can subtract that from the main area to figure out the area of the larger square. And when you subtract 233 minus 64, you get 169.
Second load, please walk to your...
And so that means that the area of the larger square that we have here is 169. It's 169. Now, if our area is 169, we need to take the square root of that in order to find the side length. The square root of 169 is 13. So that means all of these edges here are 13. And so our long edge here is going to be 13 plus 8. And when you add 13 plus 8, you should get 21. She needs 21 feet of railing in order to make the long edge.